Good evening, everyone. Am I audible? Can anyone just confirm that?
Yes, sir, you're audible.
Yes, sir.
Okay, thank you. So let's wait for one more minute and then we'll begin.
স্যার বলছিলাম লাস্ট দিনের ক্লাসের পিডিএফটা পাইনি।
ঠিক আছে প্রিয়দর্শিনী, আমি একবার কনফার্ম করে নেব। মোস্ট প্রবলি হয়তো পোর্টালে আপলোড হয়ে গেছে, বাট আইল ক্রস চেক।
আচ্ছা আচ্ছা, পোর্টালের পাসওয়ার্ডটা নেই, হোয়াটসঅ্যাপে পাঠানো হয়েছে, পাঠানো হয় প্রত্যেকদিন, এইবারটা পাঠানো হয়নি।
পোর্টালের অ্যাক্সেস নেই তোমার?
না, ওখানে তো পাসওয়ার্ডটা আমার কাজ করছে না, তারপর দেখবে বলে কিছু তো বললো না তারপর।
ঠিক আছে, আমি তাহলে হোয়াটসঅ্যাপে পাঠাতে বলে দিচ্ছি। ঠিক আছে।
আচ্ছা আচ্ছা, হ্যাঁ হ্যাঁ, পোর্টালের পাসওয়ার্ডটা ওইটাও দেখে নিতে হবে।
Hello, sir. This side Naveen. So actually, I joined a class on Friday, and today is my first class. So can you please tell me what happened on last Thursday?
Naveen, we are discussing the topic of limit and continuity of function of two variables.
Okay, sir. So where is the PDF uploaded in that in
Naveen,
your?
I can discuss all those after the class. Okay, I'll tell
Okay,
you
sir.
everything. Okay, just hold on. Okay, so I think we can start. So let me quickly pull up the screen. Yeah. So is the screen visible to everyone? Yes.
Yes, sir.
Yes, sir.
All right. So in the last class, I was trying to help you all understand the concept of existence of limit. One part we have already understood, that how we are going to disprove that if the limit does not exist, how we can go about it. We'll take one path and show that the limit varies, as a result of which we would say that the limit does not exist. Okay. So now comes the other question, that how do we prove that the limit exists, right? And for that, in the last class, I introduced this definition, that since the existence of limit can be proved only by assuring that no matter what path you take, you converge to the same point. So that is why we need to use the definition approach to the limit calculation. Okay. So this was the definition that I had put across. So did all of you understand this? Anyone having any question on this definition that I had put out along with the explanation that I had provided for people who were there in the previous class? Okay. So if this has made more or less sense to you all, then let us go a little further and try to understand this in a little bit more detail. Okay. So just like in your one variable case, continuity of a function is linked to the limit. So in the exact same way, for the multivariate case as well, we have the continuity attached to the limit. Okay. So let me just start with this and then we'll come back to discussing how we are going to solve those questions. Okay. So for the timing, let me start with this continuity of function ux comma y. Okay. Sorry for the interruption. Let's come back. So suppose we take this point a comma b. So a function u of fx comma y is continuous at the point a comma b if limit xy tends to a comma b fxy is equals to function of, okay, if the limit is equals to the functional value at that point. So obviously, just like in the one variable case, if the limit does not exist, then obviously the function will not be continuous at that point. Okay, so you all can put that as a note, that therefore if limit does not exist at the point, then the function will not be continuous. Okay, so since the idea of continuity as well is linked to the idea of limits, so just like we had given that epsilon delta definition for limit, we can apply that similar kind of idea for continuity as well. So for continuity of function, what should happen? The limit value should be equals to the functional value at that point, right? The point at which you are checking the continuity. So if I want to just modify that definition a little bit, then I would say that the previous limit definition, so the definition that how we are going to solve this, we can say that a function f of xy is continuous at point a comma b if for any epsilon greater than 0 such that mod of fxy minus function of fab less than epsilon whenever x minus a whole square plus y minus b whole square less than delta square. Yeah, all of you got this? So what I have basically done कि continuous होने के लिए क्या होना होगा, the limit value should be equals to the functional value. In the limit definition इसके जगह में हमारा L था, तो अगर मुझे continuity भी prove करना है, then it will simply mean that I will replace the functional value AB at that point and check whether these two things hold or not. कि अगर आप एक epsilon ले लो, then the mod difference should be less than epsilon whenever x minus a whole square plus y minus b whole square should be less than delta square. And if you all remember the previous class's diagrammatic interpretation that I have given you, what does this imply? It basically implies a circular neighborhood around a comma b. Correct? This is what it basically implies graphically. So what we want to do is that to prove that existence of limit or continuity for that matter, we are going to use the idea of this definition to show the continuity at the point. Okay. So for the beginning, you can understand it in this way कि अगर मुझे prove करना है that the function is continuous, these two equations or inequalities, whatever you want to say, should hold simultaneously. Okay. मतलब अगर पहला वाला होल्ड करता है देन सेकंड वाला भी होल्ड करना चाहिए, और अगर सेकंड वाला होल्ड कर रहा है देन फर्स्ट वाला भी होल्ड करना चाहिए. ओके, सो लेट्स स्टार्ट विद एन एग्जांपल. सपोज वी स्टार्ट विद दिस क्वेश्चन. fxy is equals to xy divided by under root x square plus y square when x and y not equals to 0 0, and it is equals to 0 when xy equals to 0 0. Okay, we want to check continuity at the point 0 comma 0. Okay, suppose this is the question that we want to understand, and since we are going to do it in this way, let us see how we are going to use this definitional approach over here. Mod of fxy minus f of ab less than epsilon whenever x minus a whole square plus y minus b whole square less than delta square. So suppose you start with this mod of fxy minus f of 0 comma 0, in this case less than epsilon. Okay, suppose you start with this. So fxy is what? This was basically under root xy divided by under root x square plus y square. Correct? And function of 0 comma 0 is less than, is a function of 0 comma 0 is 0. So this basically becomes mod of this entire thing less than epsilon. All right. Now, if you look at this left hand side carefully, only the left hand side, the right hand side epsilon will remain. Can I write this as mod of xy in the numerator divided by under root x square plus y square? Correct? And this can be written as of x into mod of y divided by under root x square plus y square. Yes, Argodeep?
Sir, I got disconnected for once. Can you please tell me the question?
Yes, Argodeep, sure. So this is the question, this is the function, and we are required to check continuity at 0 comma 0.
Sir, 1 minute just.
Others, any question up till this point?
No, sir.
Yeah.
Sir, is it continuous?
Yes, sir.
Yes, it should be. It should be continuous.
Sir, because
You should be.
with some observation, like in the previous class, you have already done this question by
Yeah.
checking the limit, and
Yes.
and in that question, the limit actually exists at point 0 comma 0, and at point 0 comma 0, the value of the function is 0. That means it is matching, it is equating.
Yes, yes, correct, Arvajit. Yes. If you remember that, that's well and good. You can straight
Yeah.
away apply that. Okay.
Yes, sir.
And
Yes.
otherwise, you can just solve it out and check it. Both the ways it will be fine. Okay. So now coming back to what I was showing, कि हम इससे start कर रहे हैं. कि suppose I take an epsilon and I try to evaluate this. हमारा objective क्या है कि अगर हम ऐसे एक expression से start करें, are we reaching to somewhere like this? This is what we want to see. So what we have done, first we have substituted the expression, and now I'm only simplifying the left hand side of this expression. Okay, so the left hand side up till now is basically mod x into mod y divided by under root x square plus y square. All right, now one thing to be added over here, I'm just writing it on the side. Just see this manipulation. I think you all will be able to understand. X square is less than equals to 0. So if I add y square on both sides, x square plus y square should be greater than equals to y square. If I take the positive square root only, then can I write mod of y is less than under root x square plus y square? Correct? Do all of you agree? लिख सकते हैं इसको? And in the exact similar way, if you start with y square greater than equals to 0, same thing, add x square on both sides. And again, only take the positive square root. So that means you will get mod x less than equals to x square plus y square. So if I use these two inequalities, mod y less than equals to x square plus y square and mod x less than equals to x square plus y square, can I write that this expression that we have over here will be less than equals to under root x square y square, under root x square y square divided by under root x square y square? Correct?
Yes.
So what is that? What happened now? 1 under root x square y square will get cancelled out. So this expression is nothing but under root x square plus y square. ठीक है? Correct? Okay. So just try to understand what happened over here. We started off with this mod of xy divided by under root x square plus y square. ठीक है? जिसको हमने बोला started with less than epsilon. And if we simplify the LHS a little bit, we found that this expression is less than equals to under root of x square plus y square. Correct? So can I write that means under, therefore from simplification, we are getting this expression? Can I say this? Is it making sense?
Yes.
Correct? And now, if you simply square on both sides, the inequality will remain unchanged. So what you will have? X square plus y square less than equals to epsilon square. Now, if you represent delta as epsilon, then what do you get? Which is what? The delta circular neighborhood around 0, 0. Correct. So what did we see? कि अगर हम लोग इस expression से start करें, if we assume that this holds, then from this we are able to achieve this or get a neighborhood something like this. तो इसका मतलब क्या है? It is continuous at 0, 0. ओके आपका एप्सिलॉन के टर्म्स में एक एक्सप्रेशन निकलेगा और वहां पे अगर मैं एप्सिलॉन को सम डेल्टा के फॉर्म में लिख के एक नेबरहुड ला पाता हूं then that means what from the epsilon relationship that we started we are able to obtain a delta neighborhood ठीक है if there is one confusion that I might need to correct it a little bit over here you can write in the definition where ये जो डेल्टा है is nothing but a function of epsilon ठीक है जो एप्सिलॉन से स्टार्ट किए हैं उसी को वी विल रीराइट इट इन द फॉर्म ऑफ डेल्टा nothing hard and fast this is just so that you all can understand it or represent it better even if you don't write it explicitly in the form of a delta that doesn't mean कि आपको कोई neighborhood नहीं मिला है ठीक है this is just a conventional way of putting it कि from starting from an epsilon expression you are able to find out a neighborhood in terms of x comma y so that means what the function is continuous and अगर आपको बस लिमिट एग्जिस्टेंस प्रूफ करना है देन आल्सो द सिमिलर प्रोसेस विल फॉलो ओके इज इट अंडरस्टूड बाय एवरीवन एनी
Sir, I
क्वेश्चंस
have one question.
यस
Sir, you have written ki mod of xy, x, whole mod xy by root over x squared plus y squared is less than equal to x root over x squared plus y squared, and you have also written that it is less than e. So, sir, how can we write this? Like, if x is less than a and x is less than b, so we can't say whether a is less
No.
than b or b is less than a.
No, Gautam. Not like that. What is epsilon? It is a small quantity.
Yes, sir.
Okay. And typically what you are trying to do is that you are trying to find out a simplified expression of this modulus such that that also will be less than epsilon. Okay. That is what you're trying to do.
Yes, sir.
I getting my point or Godev? So over here, basically what we are trying to say is that so basically what is fxy? It's lying on the third axis, right? The z axis, the functional values. If I try to take a neighborhood, epsilon neighborhood, then can I get some neighborhood for the 2D plane x comma y? That is what we are trying to do. So in order to do that, what we are basically trying to do is that we are trying to simplify the functional expression. I am simplifying this, right, Orgodeep? And in the process, I'm getting
Yes,
some
sir.
less than equals to. But ultimately, my objective is ki whatever be the functional form, x, y upon whatever it is, I should be getting something in terms of x minus a, which in this case is just x square plus y square, something like this. So that is my ultimate objective. So
Sir, you
from
mean
that,
there is no definite epsilon, right?
no, Argodeep, there isn't any definite epsilon. Okay,
Okay,
and
sir,
that is where you will not be required to put any numerical value to it. Okay, it can be as
Yes, sir.
small as possible. That is how it is defined. So epsilon is something like a free variable, but just has to be a small variable. That's the
Yes,
only
sir,
thing.
got it. Yeah. Thank you.
Okay. Yeah. So if it is getting a little confusing for any one of you, just remember it in this way. एक से दूसरे को ला सकते हैं या नहीं बस. If that is a yes, continuous. If that is a no, not continuous. Finished. All right. So let me give you one more thing. And over and above, ये जो simplification है जो हम लोग इस particular question के लिए किए, it's not like कि यही simplification सब केस में चल जाएगा. Okay. No matter how you want to go about it, you can choose it. And you can apply the simplifications. Let me show you one more different kind of a question. Suppose the question is this. Fxy is equals to x into sine of 1 upon y plus y into sine of 1 upon x, where x into y not equals to 0, and it is 0 when xy is equals to 0. So we need to check continuity at the point 0, 0. Okay, this is the question. So let's try to start in a similar way. So how will we start? The first step will remain the same. Mod of fxy minus f of 0, 0 less than epsilon. Yes. And what is function of 0, 0? So that is just 0. So this is typically x into sine of 1 upon y plus y into sine of 1 upon x less than epsilon. Okay. Now again, we'll try to simplify the left hand side. Okay. Can I say that this thing is less than equals to yes, do all of you agree? Can we say this?
Yes.
It's basically that क्या कहते हैं उसको triangular inequality. Mod of a plus b less than equals to mod a plus mod b. ठीक है. Next step में I can write this as equals to mod x into mod of sine 1 upon y plus mod y into mod of sine 1 upon x. Correct? Modulus of sine is bounded. It's always less than equals to 1. Correct? So that means this thing can now be written as less than equals to mod x plus mod y. And by using the inequality that we have used previously, mod x is less than equals to x square plus y square, and mod y is less than equals to x square plus y square. So fundamentally, what are we getting at the end? 2 times x square plus y square. Okay. So what are we getting eventually? Just to summarize it from the beginning, mod of x into sine of 1 upon y plus y into sine of 1 upon x is less than equals to 2 times under root x square plus y square, and that should be less than epsilon. Okay. Is it understood by all of you up till this much? Any
Yes,
questions?
sir.
Yes, sir.
So can anyone tell me what will be the next step from this? Any guesses from anyone?
So we'll square both the sides and take 4 to the RHS.
Okay, so your focus is only on the last part of the inequality, right? All right.
So delta equals to epsilon by 2, like that.
Exactly. Correct. So 2 times under root x square plus y square less than epsilon. So under root x square plus y square less than epsilon by 2. So that means x square plus y square, if you square it out, should be less than epsilon by 2 whole square. So this time what you will take as your delta? This thing. So let delta be equals to epsilon by 2. So this gives you x square plus y square less than delta square. Okay. So that means you start from this epsilon expression and you get to this delta expression. That means fxy is continuous at 0, 0. Okay. Have all of you understood this? Any doubts on this question from anyone? So in order to solve these modulus expressions, you can use any kind of simplification, all right? But usually these triangular inequalities and this mod x less than equals to root over x square plus y squared, these things will mostly work. So just keep this in mind. So now, if you all have understood this part, so now let's move on to the next part over here, which is the partial derivatives.
Sir,
Yes.
sir, can you solve a question where we have to check the continuity at a point other than 0?
Uh, uh, from whom was this question?
Sir,
Okay.
Anisha.
Yeah. Arisha, like mostly if there's a point that is not 0, 0, then it's pretty like a polynomial that you usually have as far as the questions are considered.
Hmm?
Okay, like for example, um, suppose you have this question. Fxy equals to x squared plus 2y when x comma y not equals to 1 comma 2 and equals to 3 when xy equals to 1 comma 2. Okay, if it's a simple multivariate polynomial expression, then you can simply put the values and check it, right? You don't need to go by these definition methods and all that things. You can simply calculate this limit xy tending to 1 comma 2 x squared plus 2y. So that will be equals to 1 plus 4 equals to 5. Correct. If there is this 0 by 0 or there are these issues where just by putting the values you are not getting anything, that is where you need these kind of definitional approaches or elaborate approaches. Right, Arisha?
Yes, sir.
So that is where the 0 by 0 limit checking was more important for me to show you all, because the others you all can simply do it. If the point is not 0 comma 0, then it's pretty easy to solve for most of the questions. Okay, just like this one.
Okay, sir. Thank you.
Okay, like if you check any one of the questions that we have done before, if you simply put 0 comma 0, you are ending up with a kind of indeterminate form. So you need to evaluate it using some other technique. So that's why we discuss the other possible techniques that we can use for finding them
Okay,
out.
sir. Okay, sir. Thank you, sir.
Okay. Yeah. So coming back to this discussion of partial derivatives. Okay. So partial derivative is basically, like for example, u is a function of x comma y. So if I write del u by del x, can anyone tell me what is the meaning of this when I calculate this partial derivative of u with respect to x? What am I usually doing?
Sir, change in u with respect to change in x.
Something more?
Sir, at a very minute level, very small
A little
interval.
bit more? A little bit more?
Sir, keeping others constant. Other
Exactly. That is the difference. Because when you have a multivariate function, like in single variate, you only had differentiability or derivative, right? Because there was only one variable. But now you have two variables, x and y. Both of them are changing. So when you're basically calculating the partial derivative with respect to x, So let me just write this down once. So del u by del x, or rather at times you will often see this written as f subscript x. It is the partial derivative of u with respect to x. That is, we are trying to evaluate change in u due to change in x, keeping y constant. Okay. That means for a given value of y, we are trying to evaluate the change in the functional value due to change in only x. Okay. And similarly, if I'm calculating del u by del y, which will be denoted by this, it is the partial derivative of u with respect to y. That is, we are trying to evaluate change in u due to change in y, keeping x constant. All right. So this is how we will interpret this. Now, for example, if I give you a small example, let's say u of x comma y is equals to x squared minus xy plus 2y squared. Can you tell me what would be the partial derivative with respect to x and partial derivative with respect to y? Anyone?
2x minus y.
So twice x minus y.
Okay, that's the first one. And what about the second one?
Minus x plus 4y.
Minus x plus 4y. Okay. And if I tell you to find out the value of the partial derivative at a point a comma b, then what will you do? You simply substitute. Correct? The exact thing that you have done in the single variable case holds over here as well. Okay. All right. Moving on to a few more over here. So these are the first order partial derivatives, right? Now, if you take, let's say, the partial derivative of u with respect to x, and you again partially differentiate this with respect to x, then that can be written as del 2u by del x2 or fxx. Okay. If you take the partial derivative of u with respect to y and differentiate this with respect to y, then the notation can be del 2u by del y2, which is f5y. If you take the partial derivative with respect to x and differentiate this with respect to y, then this will be del 2u del y del x. So that will be f of yx. Okay. So the first two are the second order partial derivatives, and the last one is basically referred to as the mixed partial derivatives. Okay. Can we have any other mixed partial derivatives in this case? Can anyone tell me? One is this possibility.
fxy.
Fxy. And is there any relationship between the two mixed partial derivatives?
Yes, in case of continuous and differentiability conditions, if fxy equals to f of yx, then it satisfies.
Exactly. So if the function is continuous and differentiable, then it will be satisfied. Okay. So I'm just writing it over here. So in the case of a continuous function, so this is equals to fxy, and this is known as, you all can just keep this in mind, it is the Young's theorem. Okay. So under the Young's theorem, which says that if the function is continuous and differentiable, then the mixed partial derivatives will always be equal. All right. Now, the reason why I'm discussing all this is to get to the idea of Euler's theorem. Okay. Now, before Euler's theorem, we need to discuss one more thing. So this is how we are going to represent the partial derivatives, first order, second order, and so on. The next thing is homogeneous functions. Anyone aware of what this might mean? Homogeneous functions.
Sir, it has something formed like f of ax comma ay equal to a into f of x comma y.
Close, Argodeep, a slight correction. So
Okay.
basically you have this function of x comma y, right? Multivariate function. Okay. If you scale up x and y by a factor lambda, and if you can write the function in this form, lambda to the power r f of xy, then we say that the function is homogeneous of degree r. Okay. So basically, what does this mean? Look at the left hand side. Function of lambda x comma lambda y, right? And just write down one thing, that lambda is a scalar, any number. Okay. Function of lambda x comma lambda y is what? If you increase the x and y by the same proportion lambda, then what will be the new functional value, right? That is what the left hand side tells us. And this relationship is basically telling you that it is lambda to the power r f of x comma y. What is f of x comma y? It is the initial functional value, right? For a given x comma y, the functional value is function of x comma y. So this equation or this representation is basically telling you that if you scale up the value of x and y in the same proportion, then to what extent will my functional value be scaled up or down? Is this making sense to everyone? If you scale the value of x and y in the same proportion, then by what extent is my functional value going to be scaled up or down? Like, for example, let's say this. Function of x comma y is equals to xy divided by x squared plus y squared. Okay. If you have to check the degree of homogeneity of this, then what you will do? You will try to write down the expression of function of lambda x comma lambda y. So that will be lambda x into lambda y divided by lambda x whole square, lambda y whole square. So that becomes lambda square into xy divided by lambda square taken common x square plus y square. So that is xy plus x square plus y square. So that means what did you get? Function of lambda x comma lambda y is nothing but function of x comma y. Okay. So is this function homogeneous? Anyone?
Yes, sir.
Of what degree?
So 0.
0.
Exactly. So the moment you get this, you can basically say that this is lambda to the power 0. So that means this is homogeneous of degree 0. What about this? fxy is equals to ax plus by into sine of x by y not equals to 0. Is this homogeneous?
Sir, 1 minute.
Yeah. So what are you calculating? Function of lambda x comma lambda y.
Yes, sir, homogeneous.
Of what degree?
1.
1. Okay. Others getting this answer? Yes,
Yes, sir.
any question? So that is lambda to the power 1. So that makes it homogeneous of degree 1.
Sir, how? I mean, we can take common from ax plus by, but how do we take it with sine?
Arisha, so if you write down the expression, आपका क्या आ रहा है? अगर आप function of lambda x plus lambda y को लिखती हो, तो ये बन जाएगा मेरा a into lambda x plus b into lambda y into sine of x की जगह में क्या लिखोगे? lambda x, y के जगह में क्या लिखोगे? lambda y. तो ये जो साइन के अंदर मेरा जो लैम्डा है वो कैंसिल हो जा रहा है, राइट? सो यू आर ओनली लेफ्ट विथ द लैम्डा व्हिच इज ओवर हियर.
Oh, right, sir.
तो ये जो मेरा सेकंड पार्ट हुआ, ये पूरा चीज मेरा f of xy है. सो दैट गिव्स मी लैम्डा टाइम्स f of xy. ओके, जहां जहां x और y है दैट विल गेट रिप्लेस्ड एंड अकॉर्डिंगली इट विल हैपन. Okay, any other questions from anyone? Okay. What about this? F of xy is equals to xy sine of x square plus y square divided by x square plus y square.
It's still non-homogeneous.
Okay.
Because the trigonometric function is there.
Correct. So let's try to see it as well. If you represent it, function of lambda x and lambda y, what are you getting? So in the place of x, replace with lambda x. In place of y, replace with lambda y. sine of lambda x whole square lambda y whole square divided by lambda x whole square lambda y whole square. So this will be basically lambda square xy, and from the denominator you'll have lambda square x square plus y square, and this will be sine of lambda square into x square plus y square. So although these two lambda squares get eliminated, but the whatever is remaining is not the function of x comma y, right? It is this. This lambda square is not coming out of the bracket. So this is not homogeneous. Okay. Got it, everyone? Any questions? All right. We are almost nearing the time, but just give me 5 minutes today, okay? We'll just complete this part. So with these two things understood, the idea of partial derivatives and the idea of homogeneous functions, so what we ultimately want to discuss with this is the Euler's theorem. Okay, so the Euler's theorem basically states that if f of x comma y is, okay, 1 second. Yeah. Let us continue with the notation u. If u equals to function of x comma y is homogeneous of degree n, then x into del u by del x plus y into del u by del y is equals to n times u. Okay. We are not getting into the proof of this, but just for a result, we can understand this. Okay, x into del x, yes.
Sir, what about the second higher order differentiation?
You mean the second order derivatives relation from the Euler's theorem?
Yes, sir. Sir.
Yeah, man. We'll come to that. We'll come to that. We'll have to start with the first order, right? We are starting with that. All right. This is the first order relation of the partial derivative, that x into del u del x plus y into del u del y is equals to n times u. Okay. So particularly, this is the application of the idea of your partial derivatives and this homogeneous part. So if a function is homogeneous, then you can straightforward use this expression. All right. Let me close with one question today so that it's easier for you all to understand. For example, suppose if u is equals to tan inverse of x cube plus y cube divided by x minus y, then x times del u by del x plus y times del u by del y equals to how much? Putting four options: sine of u, cos of u, sine of 2u, cos of 2u. Okay, So the hint over here is that whenever you see this kind of an expression, right, you can relate it to the Euler's theorem. That is why this will come in handy in your exams. X into del u del x plus y into del u del y. So something related to the Euler's theorem would be your most common guess. Okay. But the problem over here is that, so this is your function of x comma y, right? Correct? Can any of you check and tell me if this is homogeneous? If you take lambda x comma lambda y, is this homogeneous?
No, sir.
No, sir.
It's not
No, sir.
homogeneous. So if the function that is given to you is not homogeneous, then what can we do? So this is not homogeneous, right? So you cannot write this as some lambda to the power r or n, something like that. So therefore, not homogeneous. But, so the function is tan inverse of this expression. If you write z equals to tan of u as x cube plus y cube by x minus y, is this homogeneous?
Yes, sir.
Yeah. So if I define z as g of x comma y, let's say, then this is homogeneous, right? Of what degree?
2.
Homogeneous of degree 2. So although the original function on which you are given this kind of a Euler's representation is not homogeneous, but if you slightly manipulate it, you can see that one part is homogeneous. So you can't apply the Euler's theorem on U, but you can apply Euler's theorem on Z, right? Correct? We can apply that. So that means if you apply Euler's theorem on Z, then what you should get? X times del U by del Z, sorry, del Z by del X plus Y times del Z by del Y is equals to 2 times Z. Correct?
Yes, sir.
And now what is required in the question? You need the expression with respect to U, right? So what is U? U और Z में relationship क्या है? Z is equals to tan U. So replace it. Del X of tan U plus Y times del Y of tan U is equals to 2 times tan of U. Okay. Now I leave this to you as a homework. कि इस step से try to find out the expression for this. X times del U del X. You will solve this to find out the expression for this. Equals to given. Okay. Just give it a try. So what we have done, the original function that is given, if it is not homogeneous, then you can just take a transformation so that the part that is homogeneous, you can apply Euler's theorem, and then we will be just doing the calculation to represent it in the otherwise form. Okay. Is this understood by everyone?
Yes, sir.
Okay.
Yes, sir.
Sir,
Yes. Yes.
so
Yes.
can you just wait for 1 minute?
Yes. Yes. I can wait. Any other questions from anyone on this? Okay. Perfect. So that's it for today's class, all of you. So I'm stopping the screen share. Thank you all for joining. If you all have no other questions, then you all can disconnect. Thank you. See you all in the
Sir, I
next
have a
class.
question.
Yes, and just wait. Then we can discuss. Okay. Maybe I can take one by one. Naveen, you were asking me something. Can you just tell me in the beginning of the class? Okay, maybe he's not there. Anyone else? Maybe Orgodeep? What you wanted to ask?
Sir, I was just thinking about this solution. So I think that we can apply chain rule here. If we can multiply
Yes,
both,
yes, yes. Yes. Multiply both with
uh, sir, 1 minute. Del u, del tan u.
del u del tan u.
Yeah.
Naki, del of tan u with respect to x into del u by del x. That is the chain rule expression, right? Chain rule is first differentiate tan, so that will become sec square u into derivative of u with respect to x. So
No,
that
no,
will
sir.
become
Actually, here we have del of tan x. In the first part, x into del tan u del x, and we need to reach del of u by del of u del x. So I am
yes.
thinking like we need to multiply both sides with del u del tan u. I mean, we can
You
simply do.
can do that. Yeah, you can
Yeah,
do
yeah.
that as well, Argodip. Maybe if you can reach the answer, just we can cross check it. Okay.
Sir, do you know the answer now?
Uh, the degree of homogeneity is 2. So probably I think C or D. I don't remember exactly. It will be either sine to you or cos to you. Either one of them. Because the 2 will get adjusted somewhere, right?
Yeah, sir. Sir, I think it's option C.
Okay. We'll check that in the next class. Okay, Argodip?
Okay, sir.
We'll just discuss it once for everyone, and then it will
Okay.
be clear. Okay. Yeah. Yes, anyone else?
Yes, sir.
Yes.
Sir, is there any mock test available for QMS in the application?
Yes, it is available. Okay, just hold on. I think I can provide you all a number on the chat. You all can contact on this number to start with your mock test. Okay, just give me a minute.
Because I am not finding it in the portal, not in the application actually.
No, 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 no. It's not directly in the portal. So if you contact on this number, they'll start. Okay, just a minute. 9. Others also on the call, you can take note of this number. So for any details on the mock test, you can contact on this number. Okay. I've put it on the chat. You all can just copy it.
Okay, and sir, one more question. In QMS syllabus, there is probability. I already talked to you relating this.
Orgojit, it's there. It's there. It's there on the portal. Probably you're not being able to find it correctly. If you connect on this number, that doubt will also be clarified. Okay.
No, sir, actually, I connected with them. I talked to them for the. I've been talking to them
No,
for the
no.
last 14 days, but
Uh,
they're not actually
Orgojit,
responsive.
have you contacted on this number?
Yeah, yeah.
Uh, it should be there. Like even I have.
They told me that
Uh,
they would let me talk to Sourav sir, but they didn't actually make any arrangement for that. And I've been waiting for the last two
Okay,
weeks.
okay, Argojit. I'll personally arrange that for you to
And
talk
there
to
is
Saurabh sir.
no such recording related to probability, and there was no such topic assigned to me
Uh,
about probability topic in the series.
that will not be the case, Argojit. There is something some error somewhere. That is not the case because probability this topic the recorded lectures will be there. Okay, Argojit. I'll personally arrange
Yes,
a
sir. Please, sir,
talk
do
with
it. But
Saurabh sir.
because
Yeah,
I've been waiting for the last 14 days or more than that.
yeah, sure.
So
I'll
thank
do
you.
it. Yeah.
Sir, Sir, the mock test for MTech CS will also be available using this number.
Yes, Devanjan, yes.
Okay, sir. And sir, the recordings of the classes in the January are uploaded. I could not find them. I was able to find up to the last year's December.
Devanjan, we have only had one or two classes, I think. One class, I think, in Jan. So that will be uploaded within this week, if not
Okay, sir.
uploaded by now.
Okay, sir. Thank you, sir.
Um, good afternoon, sir. Good evening, sorry. Today is my first day joining the
Okay.
class. And were there any previous classes before this?
Previous classes, as in, like, I couldn't follow you. So this is your first class, right?
Yeah. So is this the
Yeah.
is this
So
a fresh batch or like?
so this is the batch for the 2024 exams. Okay.
Yeah. And
So
when
we
did the
had
classes? Okay.
I don't exactly recall that.
Okay, that's
Uh,
fine. But like there were
yeah.
classes before this, right?
Yeah. We had some classes before this to discuss the limits and continuity, the introductory classes that we
Okay.
had.
And how can I follow up with? How can I catch up with this?
So basically you will be getting access to a student portal, right? So what I was telling the others.
Okay.
So there we have the recorded lectures and you can just have a look at them.
Okay.
That will be helping you. Okay, along with the what do you call that? The PDF of the notes that I'm basically discussing in the class. You'll have both in
Okay.
hand. Whichever one is convenient for you, you can go about it in that way.
Yep. Thank you.
Yeah.